x squared minus bracket 2 plus p bracket x plus 7 plus p equals 0 has roots that differ by 1. Find the value of p given that p is greater than 0. So we have an expression like this: plus p into x plus 7 plus p equals 0. So the coefficient of x is minus 2 plus p, and the constant is 7 plus p. Therefore, and we are told that we have then the roots alpha and alpha plus 1. Therefore, alpha plus 1, that is sum of the root, is minus 2 plus p. And that gives us 2 plus p. So 2 alpha plus 1 is equal to 2 plus p. We are also told, and then the products, which equals to alpha squared plus alpha, is equal to 7 plus p, since coefficient of x squared is 1. Now, we have a term in alpha squared. Let us square this first equation. Let's square the first. Okay, let's make it like this. Therefore, 2 alpha, okay, plus 1, yes, is equal to 2 plus p. So let's square both sides so that we can get term of this nature. So we can now say 4 alpha squared plus 4 alpha plus 1 is equal to 4 plus 4p plus p squared. Now, you can see that we have a term like this here. We can 4p squared. Then you can now say 28 plus 4p plus 1 is equal to 4 plus 4p plus p squared. So if I subtract 4p from both sides, this one you cancel. Therefore, I can now say 29 equals to 4 plus p squared. Therefore, subtracting 4 from both sides, I'm going to have p squared is equal to 25. Therefore, p is equal to plus or minus 5. But we are told that p is greater than 0. Since p is greater than 0, p must be positive and is equal to 5. So we have got to the value for p. If a plus b equals minus 3 and a squared plus b squared equals 7, find the value of ab and let's write down the quadratic equation roots a and b. Now, we have a plus b equals minus 3 and a squared plus b squared equals 7. Let us square the first equation. Let's square it. So we are going to have a plus b all squared is equal to a squared plus b squared plus 2ab is equal to 9. That is minus 3 squared. Now let us subtract this one from this one. So we are going to have 2ab equals 9 minus 7, which is 2. Therefore, ab is equal to 2 over 2, which is 1. So ab is equal to 1. We are now told to find a quadratic equation with roots a and b. Now, quadratic equation expression is x squared minus sum of roots into x plus product of roots equals 0. So we know x squared, and so what is the sum? Minus 3. The sum is minus 3. So here will be minus 3 into x. And what is the product? ab plus 1. So the quadratic equation is x squared plus 3x plus 1 equals 0. So that's the quadratic equation. If x squared plus bx plus c equals 0 has roots alpha and beta, prove that a, if alpha equals to 3 beta, then b squared equals to 16 over 3c. b, if alpha equals to beta minus 2, then b squared equals to 4 into c plus 1. The equation is x squared plus bx plus c equals 0. And we have this information for the first part, that alpha equals 3 beta. Therefore, we can say the sum of the roots is equal to beta plus 3 beta. And that is 4 beta. Products of roots will be equal to beta times 3 beta, which is 3 beta squared. And we can find this one to be minus b, and this one is c, because the coefficient of x squared is 1. Now, because we have a term in beta squared here, let's say beta squared is equal to c over 3. And here, beta is equal to minus b over 4. Beta squared is equal to minus b over 4 squared, which is b squared over 16. Since you have b squared, beta squared now, you can say c over 3 is equal to b squared over 16. So for us to get this expression now, we can now multiply both sides by 16. So we have b squared equals to 16c over 3. So when the relationship between the roots is that one is 3 times the other one, this is the answer. B squared will be 16c over 3. Now for the second one, we have alpha equals to beta minus 2. Therefore, we can say beta is equal to alpha plus 2. So sum will be equal to alpha plus 2, which is 2 alpha plus 2. Products of roots will be equal to alpha into alpha plus 2, which is alpha squared plus 2 alpha. Alpha squared plus 2 alpha. Now, we want to find the relationship here. The sum here is equal to minus b, and the product here is c. From our prerequisite knowledge. So we can have alpha plus 1 is equal to minus b over 2. If we divide that one by 2. Now let us now square this one. We are going to have alpha squared plus 2 alpha plus 1 is equal to b squared over 4. And this place too, we see that alpha squared plus 2 alpha is equal to c. So we can say c plus 1 is equal to b squared over 4. Therefore, b squared will be equal to 4 into c plus 1. So we have done the 2. Quadratic equation px squared plus qx minus 16 equals 0 has roots alpha and beta. If alpha plus beta equals to minus half and alpha beta equals to minus 8, find the values of p and q. So we have this equation px squared plus qx minus 16 equals 0. And the roots are alpha, beta. We also told that alpha plus beta equals minus half, and that is minus q over p. We are told that alpha beta is equal to minus 8, that is minus 16 over p. So p is equal to minus 16 over minus 8, which is equal to 2. Now, I will put p in this original position. So I have minus half equals to minus q over p, which is minus q over 2. So minus q is equal to minus 1 times 2 over 2, which is minus 1. So q is equal to 1. P equals to q equals 1. The quadratic equation x squared plus 2x minus 6 equals 0 has roots alpha and beta. Find the values of alpha minus beta all squared and 1 over alpha squared plus 1 over beta squared. So this first one, the equation is x squared plus 2x minus 6 equals 0. And from here, sum, that's alpha plus beta, is equal to minus 2. Alpha beta is equal to minus 6. So alpha minus beta squared is equal to alpha plus beta all squared minus 4 alpha beta. And that will be minus 2 all squared minus 4 into minus 6, which is 4 plus 24. That's 28. The other one is 1 over alpha squared plus 1 over beta squared, which is beta squared plus alpha squared over alpha beta all squared. What is beta plus alpha squared? That is alpha plus beta all squared minus 2 alpha beta. And then the denominator still remains the same. Alpha plus beta, that's minus 2. And that is minus 2 all squared. Minus 2 into minus 6 over minus 6 squared. So this gives me 4 plus 12, 16. Minus 6 squared, that's 36. So we can divide further, and this will give us 4 over 9. That's the 6. A quadratic equation has roots alpha and beta. Given that 1 over alpha plus 1 over beta is equal to half, and alpha squared plus beta squared equals to 12, find two possible quadratic equations that satisfy these values. So we have alpha squared plus beta squared, which is alpha plus beta all squared minus 2 alpha beta to be equal to 12. And then 1 over alpha plus 1 over beta, which is beta plus alpha over alpha beta is equal to half. Now, I can now say that alpha plus beta is equal to alpha beta over 2. Now, let me substitute this for alpha plus beta in this place. So I can now say alpha beta over 2 all squared minus 2 alpha beta is equal to 12. So this one will eventually become alpha beta all squared over 4 minus 2 alpha beta, okay, minus 12 equals 0. Let me multiply 2 by 4. So I'm going to have alpha beta squared minus 8 alpha beta minus 48 equals 0. So this can now be alpha beta all squared minus 12 alpha beta plus 4 alpha beta minus 48 equals 0. So I can now say alpha beta minus 12 into alpha beta minus 12 plus 4 into alpha beta minus 12 equals 0. So alpha beta minus plus 4 into alpha beta minus 12 equals 0. So the product alpha beta is equal to 12 or minus 4. So we have alpha beta to be like that. Now let's check it one by turn. When alpha beta is equal to 12, you can see when alpha beta is equal to 12, alpha plus beta will become alpha beta over 2. So alpha plus beta will become alpha beta over 2. That is 12 over 2, which is equal to 6. So the quadratic equation here will be x squared minus the sum 6x plus the products. So when alpha beta is equal to minus 4, alpha plus beta will be equal to minus 4 over 2, which is minus 2. So the quadratic equation will be equal to x squared minus minus 2, that is plus 2x minus 4, which is equal to 0. So those are the two conditions, two quadratic equations. The quadratic equation 3x squared plus 2x minus 4 equals 0 has roots alpha and beta. Find the values of s1, s2, and s minus 1. The equation is 3x squared plus 2x minus 4 equals 0. So s1, which is summation alpha, is equal to minus 2 over 3. That's standard. S2, we know from the formula, we can find it or we can use the recurring method here. So let's use the formula. We are going to have summation alpha all squared minus 2 summation alpha beta. And in this instance, our summation alpha is minus 2 over 3 squared. And our summation alpha beta is minus 4 over 3. So we have minus 2 into minus 4 over 3. This is equal to 4 over 9 plus 8 over 3. So the LCM is 9. So I have 4 plus 24, which is 28 over 9. That's 28 over 9. Now, you have to find s minus 1. S minus 1 is equal to summation 1 over alpha, which is summation alpha over summation alpha beta. And what is summation alpha? Minus 2 over 3. What is summation alpha beta? Minus 4 over 3. So which is minus 2 over 3 times 3 over minus 4. So this one cancels this. So that is half. We can also use recurring method. If I want to use recurring, quadratic equation 4x squared minus x plus 6 equals 0 has roots alpha and beta. A, find alpha squared plus beta squared. B, what does the value of part A tells you about the roots? So the equation is 4x squared minus x plus 6 equals 0. S1 is equal to minus 1 over 4, which is 1 over 4. I want to use recurring method here. So we can now say 4s2. Yeah, this one is summation alpha. 4s2 minus s1 plus 6 equals plus 6 times 2, sorry, equals 0. So we can now say 4s2 minus 1 over 4 plus 12 equals 0. Now I can now say 4s2 plus 11 3 quarter. Okay, let me make it like this. This one is 48 plus 47 over 4 equals 0. So s2 is equal to minus 47 over 4 times 4, which is minus 47 over 16. So that's what it says. Now, this one makes us to realize that the roots are complex because the sum of the squares of the roots is giving us negative number. The sum of the squares of the roots gives negative value. Therefore, the roots are complex number. Given that 2s2 plus 5x squared plus 1 equals 0 has roots alpha, beta, gamma, and that Sn equals to alpha raised to power n plus beta raised to power n plus gamma raised to power n, find the values of s2 and s3. The cubic equation is 2x cubed plus 5x squared plus 1 equals 0. And then, you know what s2 is summation alpha squared. And we can use our formula to get that. We can say summation alpha all squared minus 2 summation alpha beta. And s1 is summation alpha, which is minus 5 over 2. So s2 will be equal to minus 5 over 2 squared minus 2. What is our alpha beta? Our alpha beta is 0 since we don't have anything in x. So alpha beta, our summation alpha beta is 0, is equal to 25 over 4. So our s2 is 25 over 4. Now to find s3, we can still use formula. We have a formula for that. That is summation alpha all cube minus 3 summation alpha beta plus 3 summation alpha beta and gamma. We know this one. We know this one. This one is summation alpha beta gamma is minus 1 over 2. Therefore, s3 is equal to minus 5 over 2 cube minus 3 into minus 5 over 2 to 0 plus 3 into minus half. And this gives us minus 125 over 8 minus 3 over 2. And that is 125 minus 125 minus 12 over 8, which is minus 137 over 8. So the answer is minus 137 over 8. So we can easily use formulas for this. The cubic equation s cubed plus ax squared plus bx plus a equals 0 has roots alpha, beta, gamma, and the constants a, b are real and positive. Find in terms of a and b the values of summation alpha and summation 1 over alpha. B. Given that summation alpha equals to summation 1 over alpha, does the cubic equation have complex roots? Let's check. We have this x cubed plus ax squared plus bx plus a equals 0. So summation alpha will be equal to minus a because coefficient of s cubed is 1. Summation 1 over alpha is going to be summation alpha beta over summation alpha beta gamma. And this is going to be b over minus a, which is minus b over a. So that is for the first part. The b part is this. It says that summation alpha is equal to summation alpha 1 over alpha. That is minus a equals to minus b over a. So minus a squared is equal to minus b. Therefore b is equal to a squared. We are now asked, does it contain complex roots? The only way we can confirm is by getting sum of the squares of the roots. That is, we are going to find summation alpha squared. If it is negative, That's where we can know. That's what can give us the hint. And that is summation alpha all squared minus 2 summation alpha beta. And what is summation alpha? That is minus a. What is summation alpha beta? That is b. And this is going to give us a squared minus 2. You can see b is equal to a squared. 2a squared. B is equal to minus a squared. Mind you, we have been told that the constants a, b are real and positive. So which means that minus a squared is negative. Therefore, it's the roots, the cubic equation has complex roots. So this has given us the hint that it has complex roots. The cubic equation s cubed minus x plus 3 equals 0 has roots alpha, beta, and gamma. A, find s4. B, by considering s1 and s4, determine the value of alpha cube multiplied by beta plus gamma plus beta cube multiplied by alpha plus gamma cube multiplied by alpha plus beta. Now we have this equation s cube minus x plus 3 equals 0. From this equation, we can see that s1 is equal to 0. We don't have any term in x squared, so that means that coefficient of s squared is 0. We can get our s2 as well, and that's going to give us, that is summation alpha all squared minus 2 summation alpha beta. And what is summation alpha? That is 0 minus 2. What is summation alpha beta? That is coefficient of s, and that is minus 1. So s2 is equal to 2. S2 is equal to 2. Now, we want to find s4. Let's multiply this by x all through. So we are going to have x raised to the power 4 minus x squared plus 3x equals 0. Now let's express it in terms of s, the sum of the roots. So this is going to be s4 minus s2 plus 3s1, which equals to 0. We don't have any constants again. Now, what is our s2? 2. What is our s1? 0. So s4 is equal to 2. Now the next one is saying that this, we should find the value of this expression. So we have alpha cube into beta plus beta cube into alpha plus gamma cube into alpha plus beta. We are going to find it. So let's see what we can do about this. So let's make it like this: alpha cube into alpha plus beta plus gamma minus alpha. So I added alpha here, I subtracted it again, so it still retains. Plus beta cube into alpha plus beta plus gamma minus beta. Plus gamma cube into alpha plus beta plus gamma minus gamma. So it's now going to give us alpha cube into alpha plus beta plus gamma minus alpha raised to the power 4. This one multiplied by this minus alpha raised to the power 4 plus beta cube into alpha plus beta plus gamma minus beta raised to the power 4 plus gamma cube into alpha plus beta plus gamma minus gamma raised to the power 4. So at the end of the day, we are going to have alpha cube plus beta cube plus gamma cube into alpha plus beta plus gamma minus alpha raised to the power 4 plus beta raised to the power 4 plus gamma raised to the power 4. So if you look at this, you don't have any problem with this because this one is 0. So the answer is going to be minus alpha raised to the power 4 plus beta raised to the power 4 plus gamma raised to the power 4, all brackets. And what is our alpha raised to the power 4? That is s4 minus s4, which is minus 2. So that's the answer to that. So the answer is minus 2. The cubic polynomial 2s cubed minus x squared plus x minus 5 equals 0 has roots alpha, beta, and gamma. Find s minus 2. B. The cubic equation px cubed plus qx squared plus r equals 0 has roots alpha, beta, gamma. Find the terms of pq, r. 1, s1, 2, s2, 3, s3. For the first part, we have this equation 2s cubed minus 2x squared plus x minus 5 equals 0. And we have to find s minus 2. we can use formula, but let's go ahead with this. Now, let's divide through by x squared. So we are going to have, okay, before we divide through, let's find s1, and that is minus 1 over 2, and that is half. So that is s1. Now, let's divide through by x squared. So we have 2x minus 1 plus x raised to the power minus 1 minus 5x raised to the power minus 2. So we have 2x minus 1 plus x raised to the power minus 1, 5x. Now, let's express it as in terms of the sum. So we have 2s1 minus 3 plus s minus 1 minus 5s minus 2 equals 0. So we've gotten s1. Now let's get s minus 1. That one is also very easy. It's summation alpha beta over summation alpha beta gamma. And what is summation alpha beta? That is 1 over 2. What is summation alpha beta gamma? That is minus 5 over 2. So we are going to have 1 over 2 times 2 over 5. So that is 1 over 5. With this information we have, we can easily solve and find s2. S minus 2 rather. So we have 2 into half minus 3 plus 1 over 5 minus 5s minus 2 equals 0. This is 1. So this is going to be minus 2. So this place will give us minus 9 over 5 minus 5s minus 2 is equal to 0. So 5s minus 2 is equal to minus 9 over 5. So s minus 2 is equal to minus 9 over 5 times 5 minus 9 over 25. So we've got to that one. So here we have this equation: px cubed plus qx squared plus r equals 0. So this first one, s1 is equal to minus q over p. Now s2 is equal to summation alpha all squared minus 2 summation alpha beta. But you can see that the term in x is missing. So which means that summation alpha beta is 0, which will be equal to minus q over p all squared minus 2 into 0. So s2 is equal to q squared over p squared. Now for s3, let's do the formula. Or we make it, or we use recurrence. Okay, let's try this recurrence then. So we have p s3 plus q into s2 plus 3r is equal to 0. So we have p s3 plus q, and this one is q squared over p squared plus 3r equals 0. So let's divide through by p. So I have s3 is equal to q plus qq over pq plus 3r over p equals 0. So s3 is equal to minus qq over p minus 3r over p. So s3 is equal to minus into qq over pq minus 3r over plus 3r over p plus 3r over p. The equation x cubed plus px squared plus qx plus r equals 0 is such that s1 equals 0, s2 is minus 2, and s minus 1 is 1 over 5. Find the values of p, q, and r. We have this equation. X cubed plus px squared plus qx plus r equals 0. We know that s1 is equal to minus p over coefficient of x cubed, and we know that s1 from the is 0. Therefore p is equal to 0. Now for s2, we know that s2 is equal to summation alpha squared minus 2 summation alpha beta. Summation alpha is equal to p, which is 0, is equal to, that is s1. S1 is summation alpha, which is p, equal to 0. Summation alpha beta is equal to q, and you are told that S2 is minus 2. So we have minus 2 is equal to 0 squared minus 2 into Q. So minus 2 equals to minus 2Q. Q is equal to 1. You have seen that Q equals to 1 now. We are also told that S minus 1 is equal to 1 over 5. And S minus 1 is equal to summation alpha beta over summation alpha beta gamma. And what is summation alpha beta? That is Q. Summation alpha beta gamma, that is minus R. This is minus Q over R equals 1 over 5. And what is Q? 1. So minus 1 over R equals to 1 over 5. Therefore, R is equal to minus 5. The quatic equation 2x raised to the power 4 plus x cubed plus minus x plus 7 equals 0 as root alpha beta gamma delta. Given that s3 equals to 11 over 8 and using Sn, find the value of S4. The quatic equation is 2x raised to the power 4 plus x cubed minus x plus 7 equals 0. And from here we can see that S1 is equal to minus 1 over 2. We are also told that S3 is equal to 11 over 8. We have to find S4. Now let's express this in terms of S. So we are going to have 2S4 plus S3 minus S1 plus 7 times 4, 28, which equals 0. So we have 2S4 plus 11 over 8 minus half plus 28 equals 0. So we have 2S4 plus 11 over 8 plus 4 over 8 plus 28 times 8 over 8 equals 0. So we have 2S4 plus 239 over 8 equals 0. So 2S4 is equal to minus 239 over 8. So S4 is equal to minus 239 over 8 times 2 is minus 239 over 16. So our value for S4 is minus 239 over 16. Given that x raised to the power 4 minus x cubed plus x plus 2 equals 0 as roots alpha beta gamma delta, find the values of summation alpha squared, summation 1 over alpha, and summation alpha cube. So we have this equation x raised to the power 4 minus x cubed plus x plus 2 equals 0. Observe that we don't have any term in x squared. Now we have to find summation alpha, and that is minus 1 over 1, the coefficient of this one and this one. So we are going to have this one as 1. Summation alpha squared is equal to summation alpha all squared minus 2 summation alpha beta. And this is going to give us 1 squared minus 2. And summation alpha beta is going to give us to be 0. We don't have any coefficient, anything in x. So this is 1 as well. Summation 1 over alpha is going to be summation alpha beta over summation alpha, summation alpha beta gamma over summation alpha beta gamma delta. And what is alpha beta gamma? That is minus 1 over 1, and alpha beta gamma delta is 2. So summation 1 over alpha is minus half. Now let's use recurrence to get our S3. That is summation alpha cube. Dividing 2 by x, we are going to have x cubed minus x squared plus 1 plus 2 x raised to the power minus 1 equals 0. Now, let's express in terms of s, the sum of the roots. So this is going to be s3 minus s2 plus 4 plus 2s minus 1. And what is our, so we know our s2 and s minus 1. So we have s3 minus, what is our s2? 1 plus 4. What is our s minus 1? Minus half. So we have s3 minus 1 plus 4 minus 1 is equal to 0. So s3 plus 2 equals 0. So s3 is equal to minus 2. And that is summation alpha cube. So our S3 or summation alpha cube is equal to minus 2. The polynomial x raised to the power 4 plus ax squared plus bx plus 1 equals 0 as root alpha, beta, gamma, delta. Find the value, given that s2 equals to s minus 1, find s3 in terms of a. Here, we have this equation x raised to the power 4 plus ax squared plus bx plus 1 equals 0. S1 is equal to 0 because we don't have anything in s cubed. Our s minus 1 is equal to summation alpha, beta, gamma over summation alpha, beta, gamma, delta. And this is going to be minus b over 1 divided by 1. So this is minus b. S2. We are told that S2 is equal to S minus 1. So S2 is equal to summation alpha all squared minus 2 summation alpha beta. And we know this one to be 0 squared minus 2. Now what is summation alpha beta? That is 8. And that is therefore S2 is equal to minus 2a. Let us divide the main equation by x. So we have x cubed minus 8 plus ax plus b plus s minus 1. Let's express in terms of x. We have s3 plus as1 plus 4b plus s minus 1 equals 0. And here, we can see that minus b is equal to minus 2a. Therefore, b equals 2a. Let's establish this fact. Now, let us now put everything that we can express in terms of a or in terms of a in the equation. We have s3 plus a, and what is s1? 0 plus 4. What is b? 2a plus s minus 1, and what is s minus 1? Minus b. And that is minus 2a equals 0. So s3 plus 6a equals 0. Therefore, s3 is equal to minus 6a. S3 is equal to minus 6a. Polynomial 3x raised to the power 4 plus 2x cubed plus 7x squared plus 4 equals 0 as root alpha, beta, gamma, delta. Find s1, s2, s3, and s4. We have this equation 3x raised to the power 4 plus 2x cubed plus 7x squared plus 4 equals 0. From here, our s1 is equal to minus 2 over 3. S2 is equal to summation alpha minus 2 summation alpha beta. And this, our summation alpha is minus 2 over 3 squared. Minus 2, what is our summation alpha beta? That is 7 over 3. So we are going to have 4 over 9 minus 14 over 3. This is 4 minus 42 over 9, which is minus 38 over 9. So that's our S2. To find S3 conveniently, we use recurrence. So to use recurrence now, let's divide through by x. So we are going to have 3x cubed plus 2x squared plus 7x plus 4x raised to the power minus 1 equals 0. So let's express in terms of x. We are going to have 3s3 plus 2s2 plus 7s1 plus 4s minus 1 equals 0. Now we know s2, we know s1, but we don't know s minus 1. And to find s minus 1 is going to be summation alpha, beta, gamma over summation alpha, beta, gamma, delta. And we don't have anything in x. So this expression is 0. Now let's work everything out. Now we have 3s3 plus 2. What's s2? Minus 38 over 9. Plus 7. What's s1? Minus 2 over 3. is equal to 0. Since this one is 0. Now let's work. We have 3x3 minus 76 over 9. This one is 14. 14 times 3 minus 42 over 9 equals 0. So we are going to have 3x3 minus 118 over 9 equals 0. Therefore, s3 is equal to 118 over 9 times 3, which is 118 over 27. Now, we want to find s4. We have gotten s3 now. So s3 is this. So with this, you can conveniently find s4. The equation is 3x raised to power 4 plus 2x cubed plus 7x squared plus 4 equals 0. Now, let's express in terms of s. So we are going to have 3s4 plus 2s3 plus 7s2 plus 16. We multiply that 4 by the degree, which is 4. So we have 3s4 plus 2 into 118 over 27 plus 7. And what is s2? Into minus 38 over 9 plus 16 equals 0. Now let me work it out. So this gives me 3s4 minus 130 over 27 equals 0. So s4 equals 130 over 27 times 3, which is 130 over 51. That is s4. We are now asked, are there any complex roots? Because we have the sum of s2 to be negative, so it shows that there will be complex roots. And complex roots appears in conjugate. So which means there have been two complex roots. Yes, there are complex roots. S2, because S2 is negative. Sum of squares of the roots is negative. Find the polynomial x raised to power 4 plus ax cubed plus bx squared plus c equals 0 with root alpha, beta, gamma, delta. It is given that alpha squared plus beta squared plus gamma squared plus delta squared equals to 0. Alpha plus beta plus gamma plus delta equals 2. And alpha, beta, gamma, delta equals to 1. Find the values of a, b, and c. So we have this. X raised to power 4 plus ax cubed plus bx squared plus c equals 0. And we are told that summation alpha is equal to 2. Therefore, minus a is equal to 2. A equals minus 2. So the product alpha, beta, gamma, delta is equal to 1. And from here we know that that is equal to c over 1, which is equal to c. Therefore, c is equal to 1. We also know that summation alpha squared is equal to 0. And we know this is equal to summation alpha all squared minus 2 summation alpha beta. And we know this one to be minus 2. So which means that minus 2 all squared minus 2 into summation alpha beta equals 0. Okay. Minus 2 summation alpha beta. Therefore, 4 equals to 2 summation alpha beta. So summation alpha beta is equal to 2. And from this place, we can see that this is equal to b. So a is minus 2, b is 2, and c is 1. The roots of the quatic x raised to power 4 minus 2x cubed plus x squared minus 4 equals 0 are alpha, beta, gamma, delta. Show that s4 equals to 9s3. Here, the equation is this: x raised to power 4 minus 2x cubed plus x squared minus 4 equals 0. Now, let's find s3. Before that, let's find s1. S1 is equal to 2. S2 will be equal to summation alpha all squared minus 2 summation alpha beta. And this is 2. So we have 2 squared minus 2 times 1, 2. And that is 2. Another thing we need to find is s minus 1, which is summation alpha beta gamma over summation alpha beta gamma delta. And in this instance, summation alpha beta gamma is 0. So this one is 0. Now, for us to find s3, let's divide 2 by x. So we are going to have x cubed minus 2x squared plus x minus 4x raised to the power minus 1 equals 0. Now let's express in terms of s. So we have s3 minus 2s2 plus s1 minus 4s minus 1 equals 0. So here now you can say s3 is equal to 2s2 minus s1. This one too now we can express it as s as sum of s. So we can say s4 minus 2s3 plus s2 minus 4 times 4 minus 16 equals 0. And from here I can find s3. What is s2? 2. What is s1? 2. So that is 2 times 2 minus 2. This is 2. Now let's substitute here. So s4 minus 2 into 2 plus 2 minus 16 is equal to 0. So s4 minus 18 equals 0. So s4 is equal to 18. Now s3 is equal to 2. s4 is equal to 18. Therefore s4 over s3 is equal to 18 over 2. Therefore s4 is equal to 9s3. So that's good. Given that x cubed plus x squared minus 5 equals 0 has roots alpha, beta, and gamma, find the cubic equation with roots 1 over alpha minus 2, 1 over beta minus 2, and 1 over gamma minus 2. 1 over gamma minus 2. Now, we have this x cubed plus x squared minus 5 equals 0. That's the solution. And we are told to find equation with root of this. We can go about it by adding, getting the sum, but that will be too long. So let's use the method of substitution. And how do we go about this? We look at what is common about this. 1 over alpha minus 1 over beta minus 1 over gamma minus 2. So if we want to use it in this equation, we are going to represent this as y equals to 1 over x minus 2. Do you understand? Because y, we are going to form another cubic equation whose roots will now be this. But when you compare the two, this new expression or equation will be in y. And each y will be 1 over x minus 2. That is, we are going to have 1 over alpha minus 2, 1 over beta minus 2, and 1 over gamma minus 2. So, in summary, this is what we are going to have as the new roots. Therefore, x minus 2 is equal to 1 over y. So, x equals to 2 plus 1 over y, which is 2y plus 1 over y. Now, we are going to substitute this into the expression for x. Therefore, the new equation will be 2y plus 1 over y cubed plus 2y plus 1 over y squared minus 5 equals 0. Now, which means I need to expand this, and then to work on this. But one thing is sure, this will be y cubed, this will be y squared, and then let me continue. So we are going to have something like this: 2y plus 1 all cubed over y cubed plus 2y plus 1 all squared over y squared minus 5. So multiply through by y cubed. Multiply through by y cubed. So we are going to have something like this: 2y plus 1 cubed plus y into 2y plus 1 squared minus 5y cubed. Now, for ease, I will arrange it. So I'm going to have 2y plus 1 cubed, then y into 2y plus 1 squared and minus 5y cubed. So this is going to be sum here plus this one is going to be minus. So what will be 2y plus 1 cubed? That's going to give me 8y cubed times 2y squared times 1. That is plus 12y squared. Again, 3 into 1 squared times 2y. That is plus 6y plus 1 cube. That one is okay. So here now I'm going to have 4y squared times y. That is 4y cube. So you know this one, the expansion of squares is, this one is going to give me 4y squared plus 4y plus 1. So I'm going to have 4y cube plus 4y squared plus y. And here I'm going to have minus 5y cube. Now, so I'm going to have 1 plus 7y plus 16y squared. This is plus 7y cube. So this is the new expression. So the cubic equation with roots 1 over alpha minus 2, 1 over beta minus 2, 1 over gamma minus 2 is 7y cubed plus 16y squared plus 7y plus 1. So please, what this means is, if the root of this is alpha, beta, gamma, the root of this one will be 1 over alpha minus 2, 1 over beta minus 2, 1 over gamma minus 2. The cubic polynomial x cubed plus 5x squared plus 1 equals 0 has roots alpha, beta, and gamma. Using the substitution y equals to x cubed, or otherwise, find the value of s6. We have to find the value of s6. So the real equation is this: x cubed plus 5x squared plus 1 equals 0. And we are going to find another cubic equation whose roots will be alpha cube, beta cube, and gamma cube. That's what this means. So we have now y equals to x cubed. Therefore, x will be equal to cube roots of y, or y is power 1 over 3. Now, we are going to substitute this into this equation. You can do it anyhow, but this is the simplest way of going about it. Just plug this one back into this equation now. So I have y raised to power 1 over 3 cube plus 5y raised to power 1 over 3 squared plus 1 equals 0. So you can see this one now. So y, because this one will give me y, plus 5y raised to power 2 over 3 plus 1 equals 0. Please note, it's the x that is squared, so that is why this one is squared. Now, for ease, I would like to put this one at the other side of the equation. You know why? Because if I want to remove this power here, I will have to cube. And if I should cube it all through like this, I find it difficult in solving it. So for ease, I have to move this one to this side. So I'm going to have y plus 1 equals to minus 5 y raised to the power 2 over 3. Now, I have gotten it like this. Let me cube both sides. So what am I going to have? I'm going to have y cubed plus 3y squared plus 3y plus 1 equals, what is minus 5 cubed? Minus 1 to 5. And this one cube is going to be y squared. You can see. So it has made the job very easy now. Now let me bring this one back into this place. So the new equation is y cubed plus 3 plus 128 y squared plus 3y plus 1 equals 0. This is the new equation. Now we have to find s6, and this s6 for x is s2 for y. So what does that mean? I'm going to find s2y. That's what it means. So s6 is equal to s2y, and I'm going to get it using the formula. So s2 is equal to summation alpha all squared minus 2 summation alpha beta. What is summation alpha? That is minus 1 to 8, minus 1 to minus 1 to 8. What is summation alpha beta? Alpha beta is equal to 3. Therefore, equals to minus 1 to 8 all squared minus 2 times 3. And what does that give? So S6 makes S S2y, sorry, is equal to S6. And that is 16,378. That is S6x is equal to S2y. 16,378. That's what I've been trying to explain. The quadratic equation 2x squared minus 4x plus 7 equals 0 has root alpha beta. Find the quadratic equation with root 2 alpha minus 3, 2 beta minus 3, and 2 alpha squared beta squared. You can do either by using the formula or substitution method. Because it is quadratic equation, it is easy using the formula. Like saying, we know what in this situation, we know what our alpha plus beta are. That is minus 4 over 2. That's 2. What is alpha beta? That is 7 over 2. So, in this instance, for the first one, we can find the sum. This is easy to use for quadratic equation. So, 2 alpha minus 3 plus 2 beta minus 3. What does that give us? It's going to give us 2 into alpha plus beta minus 6. So, what is alpha plus beta? 2. 4. That's minus 2. The product, 2 alpha minus 3 into 2 beta minus 3 is going to give us 4 alpha beta minus 6 alpha minus 6 beta plus 9. So, I can now say, what is alpha beta? 4 times 7 over 2. Okay, let me just continue. I can now say it's equal to 4 alpha beta plus 9 minus 6 into alpha plus beta. So what is 4 alpha beta? That is 4 times 7 over 2 plus 9 minus 6 into 2. So this is 14, 23 minus 12, 11. So for the first one, the new equation will now be x squared. What is the sum? Minus 2. Minus 2x plus 11 equals 0. So I have x squared plus 2x plus 11 equals 0. Now, for this alpha squared beta squared, I'm going to have alpha squared plus beta squared is equal to alpha plus beta all squared minus 2 alpha beta. And what is alpha plus beta? 2. That's 2 squared minus 2. What is alpha beta? 7 over 2. So, this gives me 4 minus 7, which is minus 3. That is minus 3. The product, alpha squared times beta squared is equal to alpha beta squared. And that is 7 over 2 squared, which is 49 over 4. So for this situation now, the new equation will be x squared minus 3x plus 49 over 4 equals 0. So multiply. So I'm going to have x squared plus 3x plus 49 over 4. So I'm going to have 4x squared plus 12x plus 49 equals 0. So for quadratic, it is very easy. But at this level, when you have this equation, go and use substitution straight. It reduces the stress and makes your job straightforward. Let's use substitution to solve this. Now, to use substitution, that makes it more interesting and easier to do. So for the first one, y will be equal to 2x minus 3. So y plus 3 over 2 is equal to x. So y plus 3 over 2 equals to x. And the original equation is 2x squared minus 4x plus 7 equals 0. So we now substitute y plus 3 over 2 for x in this place. So we are going to have 2 into y plus 3 over 2. 2 into y plus 3 over 2 squared minus 4 into 2 minus 4 into y plus 3 over 2 plus 7 equals 0. So you can see, I'm working it now. I have changed the x into y conveniently. So to differentiate the two, it makes it very easy and fun to do. Now I have 2 into y plus 3 squared over 4 minus, this one cancels this, so So I have 2 into y plus 3 plus 7 equals 0. So this one cancels this one too. So let me multiply 2 by 2. So if I multiply 2 by 2, I'm going to have y plus 3 squared minus 4 into y plus 3 plus 14 equals 0. Now I can work this out straight. So this one can just give me, let me see, y plus 3 into y plus 3 minus 4 plus 14 equals 0. And that is y plus 3 into y minus 1 plus 14. So this one is easy to expand now. So y squared plus sum plus 2y minus 3 plus 14 equals 0. So what do I have now? I have y squared plus 2y plus 11 equals 0. You can see nothing, no stress. Now for the other one, in this instance we say this is the second one. Y equals to x squared. Therefore, x equals to root of y. And the original equation is 2x squared minus 4x plus 7 equals 0. So we substitute root y for x in the equation. So we are going to have 2 into root y squared minus 4 into root y plus 7 equals 0. So this is going to give me 2y minus 4 root y plus 7 equals 0. So for ease and to make the work reasonable, because if I expand this one, I square it, I will still be having terms in root of y. So I have to move this one to this other side and square both sides. So I'm going to have 2y plus 7 is equal to 4 root y. You can see. So squaring both sides, square both sides. I'm going to have 4y squared plus 28y plus 49 equals to 16y. Now I bring this one back inside here. I have 4y squared plus 12y plus 49 equals 0. You can see the job becomes fun and easier using substitution method. Given that 3x squared minus 2x plus 9 equals 0 as roots alpha beta, find the quadratic equation with roots alpha plus 1 over alpha and beta plus 1 over beta. That is first part. The second part says, given that 2x cubed minus 5x plus 1 equals 0 as roots alpha, beta, gamma. Find the cubic equation with roots alpha squared, beta squared, gamma squared. S, find the value of S4. Now, we have shown that when you have situations like this, substitution method is the easiest and fastest. So, the first one is this. 3x squared minus 2x plus 9 equals 0. So since we have our root in this form, we can say y equals to x plus 1 over x. Now let's make x the subject of this expression. So we have xy equals x plus 1. Therefore I can now say xy minus x equals 1. So x into y minus 1 equals 1. Yeah. 1. So x equals 1 over y minus 1. That is it. X equals to 1 over y minus 1. Then I will now substitute this back into this equation. So I have 3 into 1 over y minus 1 all squared minus 2 into 1 over y minus 1 plus 9 equals 0. So since the LCM is y minus 1 cube squared, so let's multiply through by y minus 1 all squared. So what's that going to give me? 3 minus 2 into y minus 1 plus 9 into y minus 1 all squared equals 0. Please help me understand. This one, I use this one to multiply through, and that is the LCM. Now let me now expand this. I'm going to have 3 minus 2y plus 2 plus 9 into y squared minus 2y plus 1. This is now going to give me. Expanding this one, I'm going to have 3 minus 2y plus 2 plus 9y squared minus 18y plus 9 equals 0. Now gathering the like terms, I have 9y squared minus 2 minus 18, that's minus 20y. 3 plus 2, that's 5 plus 9, that's 14. Plus 14 equals 0. You can also use the other method of adding the roots and subtracting the and multiplying the roots to find it. So you can find the sum by saying alpha plus 1 over alpha plus beta plus 1 over beta. And then from here, because you have known what the alpha of this will be, the sum in this place, you know what it is. And from this place, you know that alpha plus beta is equal to 2 over 3. Alpha beta is equal to 9 over 3, which is 3. So at the product 2, alpha in this case, the new root summation alpha beta will be alpha plus 1 over alpha into beta plus 1 over beta. So, and on getting this, you know that okay, this one will be negative. The sum here, you multiply by minus 1 and put it as the coefficient of y. And this one, you put it as the constant. So you can use that one as an exercise, and I've done it. I got the same answer. Let's do the next one. So we have this equation 2x cubed minus 5x plus 1 equals 0. And you are told to find equation with roots alpha squared, beta squared, and gamma squared. So the easiest thing is to see y equals x squared. Therefore, x equals to root of y, just like the other one we did. So we now slot it in here. We have 2 root y cubed plus 5 root y plus 1 equals 0. And with this, now for ease, let me move this 1 to this side. So I'm going to have 2y raised to power 3 over 2 plus 5y raised to power 1 over 2 is equal to minus 1. Now let's square both sides. So I'm going to have this one, squaring both sides. This will give me 4y raised to power 3 over 2 squared plus 2 times 2 times 5, that's 20. Y raised to power 3 over 2 times y raised to power 1 over 2 plus 25 y raised to power half squared is equal to 1. So you can see the solution makes it very easy to do that. Therefore, this one is now going to give you 4y cubed plus 20. You know, y raised to power 3 over 2 plus y raised to power half is going to be y raised to power 3 over 2 plus half. That is 2. So y squared plus this one is going to be 25y equals to 1. So our equation is now 4y cubed plus 20y squared plus 25y minus 1 equals 0. So you can see our equation is the equation with alpha squared, beta squared, gamma squared as the roots is 4y cubed plus 20y squared plus 25y minus 1 equals 0. So this one now is, we have this equation 2x cubed minus 5x plus 1 equals 0. And since the new equation will have squares of the previous roots, so we can say y equals to x squared. So x is equal to root of y. Now let's substitute root of y for x in the equation. So we have 2 into y raised to the power half cube. This one is y raised to the power half. Minus 5 y raised to the power half plus 1 equals 0. So as it is now, if we expand on through, we are going to encounter greater problem later on. So let's move this one to this side. So you have 2 into y raised to the power 3 over 2 minus 5 y raised to the power half is equal to minus 1. Now let's square both sides. Square both sides. We are going to have this one is 4y raised to the power 3 over 2 times 2 minus 2 times 2, 4 times 5, 20 minus 20 into y raised to the power 3 over 2 into y raised to the power half, then plus 25y raised to the power half squared plus 25y raised to the power half squared is equal to 1. That is 1 squared. So by the time I do this one, it's going to give me 4y cubed minus 20. And when I multiply this one and this one, I'm going to add the powers. 3 over 2 plus half, that is 2. So that's y squared plus 25y equal. Let me now work this out. So I'm going to have y cube minus 20 y, let's see, 3 over 2 plus half, that is 2. 20y squared plus 25y is equal to 1. So the new equation is 4y cube minus 20y plus 25y minus 1 equals 0. So that's the new equation for alpha squared, beta squared, and gamma squared. Now we have to find S4. S4 is S2 for the new expression. So S4 is S2 for this one. And since we know the formula, let's quickly use the formula. For S2y, it will be summation alpha squared minus 2 summation alpha beta. What is our summation alpha y? Alpha. That is minus 20 over 4. And that is 5. What is summation alpha beta? That is 25 over 4. That's 25 over 4. Therefore, S4, which is S2y, will be equal to 5 squared minus 2 into 25 over 4, which is 25 minus 25 over 2. The answer is 25 over 2, or 12 and a half. So that's the answer. So substitution makes it very easy and fast. The cubic equation, x cubed plus 3x squared minus 1 equals 0, has roots alpha, beta, gamma. Show that the cubic equation with roots alpha plus 2 over alpha, beta plus 2 over beta, and gamma plus 2 over gamma is y cubed plus 3y squared minus 9y plus 3 equals 0. Hence, determine the value of alpha plus beta brackets into beta plus 2 brackets into gamma plus 2 brackets over alpha, beta, gamma. And b, alpha over alpha plus 2 plus beta over beta plus 2 plus gamma over gamma plus 2. Now let's first of all prove the first part. The original equation is x cubed plus 3x squared minus 1 equals 0. And we are told that the new roots, or the root of the new equation, is alpha plus 2 over gamma, beta plus 2 over beta, and gamma plus 2 over gamma. So we can just say y equals to x plus 2 over x. And from here, let's make x the subject of the formula. So we can now say xy is equal to x plus 2. And then xy minus x is equal to 2. So x into y minus 1 is equal to 2. So x equals 2 over y minus 1. Now let's substitute this into this equation now. So we can now say 2 over y minus 1 cubed plus 3 into 2 over y minus 1 squared minus 1 equals 0. Now, I can now say 8 over y minus 1 all cubed plus 3 into 4 over y minus 1 squared minus 1 equals 0. So from our observation, you can see that y minus 1 cubed is the LCM. So let's multiply through by y minus 1 cubed. So we are going to have 8 plus 12 into y minus 1 plus minus y minus 1 all cubed is equal to 0. We're going to multiply the other side too by y minus 1 is equal to 0. 12 into y minus 1 and then minus 1 into y minus 1 cubed. Now let's expand that. Plus 12y minus 1 minus 12 minus 1 into y cubed minus 3y squared plus 3y minus 1 equals 0. So I can now say 8 plus 12y minus 12 minus y cubed plus 3y squared minus 3y plus 1 equals 0. Now let me gather like terms. 8 minus y cubed plus 3y squared 12y minus 3y, that is plus 9y. 8 minus 12, that is minus 4 plus 1 plus minus 3 equals 0. Now let's multiply through by minus 1. So I'm going to have y cubed minus 3y squared minus 9y plus 3 equals 0. So that's the new equation we are looking for. So if you compare, we have gotten it. Now we have to find alpha plus 2 multiplied by beta plus 2 multiplied by gamma plus 2 over alpha beta, gamma. So what does that imply? It implies the product of these three. So the product of roots in this instance, positive, negative, is going to be minus 3 over 1, which is minus 3. Now this constant divided by the coefficient of y cube. We also asked b, alpha over alpha plus 2 plus beta over beta plus 2 plus gamma over gamma plus 2. That is, we have asked to find inverse of the roots. So the sum of the inverse of the roots. And how do we get that? For this y, please, I just don't want us to have that confusion. So this one is now going to be summation alpha beta over summation alpha beta and gamma. And I said positive, negative, positive. So this one is going to be minus 9 over 1 divided by minus 3 over 1. And that's going to be minus 9 divided by minus 3, which is equal to 3. So you can see the product is minus 3 and the sum is 3. The sum is 3. The quatic equation 2x raised to the power 4 minus s cubed minus 6 equals 0 has roots alpha, beta, gamma, delta. Show that the quatic equation with roots alpha cube, beta cube, gamma cube, delta cube is 8y raised to the power 4 minus y cube minus 18y squared minus 108y minus 206 equals 0. Hence, find the values of s6 and s minus 3. So in this instance, the original solution equation is 2x raised to the power 4 minus x cubed minus 6 equals 0. And our y now will be equal to x cubed. So x equals to y cube root of y, or y raised to the power 1 over 3. So let's substitute this for y here, for x rather. So we have 2 into y raised to the power 4 over 3 minus y times 3 minus 6 equals 0. And what does that give? It gives us 2y over 4 over 3 minus y minus 6 equals 0. So for ease, let me move this to the other side. So I'm going to have 2 into y raised to the power 4 over 3 is equal to y plus 6. Is equal to y plus 6. Now, to continue this, I have to cube both sides. I have to cube both sides. That is, that will be 2 cubed into y times 3 is equal to, so if I expand this one, it's going to be y cubed plus 3 times 6, 18 y squared, 18y squared, plus 3 times 36, that is 108y, plus 6 raised to the power 4, and that is 36 times 36, that's 216. So I can now say 8y raised to the power 4 is equal to y cubed plus 18y squared plus 108y plus 216. So the new equation will now be 8y raised to the power 4 minus y cubed minus 18y squared minus 108y minus 216 equals 0. So if you compare, we see that we have gotten this. I can easily say proved. Then find the value of s6 and s minus 3. S6 will be s2 for this, from the previous one we have been doing. So s6 will be equal to s2y, since y is equal to s cubed. So please, that's the reason. And I can now say, for this place, summation alpha y is equal to minus into minus 1 over 8. That's summation alpha y. And then summation alpha beta y is going to be minus 18 over 8. So please, this one is 1 over 8. This one is minus 18 over 8. Therefore, S6 is equal to S2y, which is equal to summation alpha y squared minus 2 summation alpha beta y. Please, I hope you understand the subscript with y I put in now, so that it will be clear to differentiate this one. So it's going to give me 1 over 8 all squared minus 2 into minus 18 over 8. And this is 1 over 64 plus 36 over 8. So this is going to give me 1 plus 36 times 8. So S6 is 289 over 64. And we have S minus 3. And that is summation 1 over alpha y. And that is summation alpha beta gamma over summation alpha beta gamma delta. And I can easily work this out. This one is 108 over 8. 108 over 8 divided by this one. So and that is minus 216 over 8. So this one will now be times 8 over 216. And that is half. That's half. So you can see how easy all these things are. Just observe and take the necessary steps. The cubic equation x cubed minus x plus 4 equals 0 has roots alpha beta gamma. Find the cubic equation that has roots alpha squared, beta squared, gamma squared. S or otherwise determine the values of S6, S8 and S10. Now let's first of all do this first part. The original equation is x cubed minus x plus 4 equals 0. So that's the solution we are doing now. And we can say that y equals to x squared. Y equals to x squared. So let's input it. X will be equal to square root of y. So let's substitute root of y for x in the equation. So we have root of y cubed minus root of y plus 4 equals 0. Root of y cubed minus so equals 0. Now let me now make this minus root of y to be equal to minus 4. Now let's square both sides. Let's square both sides. So I'm going to have cube roots squared minus 2 into square root y cubed times root of y plus root of y squared is equal to 16. So this gives me y cubed. This one is 3 over 2 and then half minus 2 into, so this will give me 2 minus 2y squared plus y equals 16. So the equation now is y cubed minus 2y squared plus y minus 16 equals 0. So this is the new equation with alpha squared, beta squared and gamma squared. The next thing now we are asked is we should find S6, S8 and S10. In this place, S6 is equal to S3y. Yes, S3y. Because each is square of this, each root here is square of the root here. Now, I can find this one using the formula. S3y is equal to summation alpha cube minus 3 summation alpha beta plus 3 summation alpha beta gamma. So this one makes it easy for me. Unless I want to start working it out one after the other. This one makes it very easy for me and straightforward. So what is summation alpha? That is minus 2 over 1. That is 2. What is summation alpha beta? 1 over 1. 1. What is summation alpha beta gamma? Minus 16. So I can now conveniently find S6. So S6 is S3y is equal to 2 cubed 2 raised to the power 3 minus 3 into 2 times 1 plus 3 into minus 16. So this is 8 minus 6 minus 48. 8 minus 6 minus So summation alpha is equal to minus 2 over 1, that's 2. Summation alpha beta 1 over 1, that is 1. Summation alpha beta gamma, that is minus 16 over 1, that is 16. Now we have known this formula, so let's substitute. So S6 equals to S3y, which is 2 cubed minus 3 into this one times this one. So minus 3 into 2 times 1 plus 3 into 16. So that gives me 8 minus 6 plus 48, and that is 50. So S6 is 50. Now for ease, for me to be able to get, what's it called? S8. S8 is equal to S4y. I have to employ recurrence method in this case. So let me multiply through by y. Therefore, y raised to the power 4 minus 2y cubed plus y squared minus 16 equals minus 16 times 3. Sorry. Yes, minus 16 is equal to 0. So y raised to the power 4. So I have to multiply this one again by y. So I have y raised to the power 4 minus 2y cubed plus y squared minus 16y equals 0. So if I should convert it to the sum after adding, and I want to express it in terms of s, I don't have any constant here. So I'm going to have s4 minus 2s3 plus s2 minus 16s1 equals 0. So for me to get s4 now, it is mandatory for me to get s1 and s2. S1 is already known. S1 is 2. S1 equals to 2. S2, that's what I'm going to find now. S2 is equal to summation alpha all squared minus 2 summation alpha beta. So S2 is equal to, what is this one? 2. 4 minus 2 summation alpha beta, that is 1. So S2 is equal to 2. We have gotten that one. S2 is equal to 2. So now, let me now substitute this one, and this one in this equation here. Therefore, I have S4 minus 2 into S3, which is 50, plus, what is S2? 2, minus 16 into S1. What is S1? 2 is equal to 0. So I have S4 minus 100 plus 2 minus 32 is equal to 0. So S4 minus 130 is equal to 0. So let me put it like S4y. So S4y is equal to 130, and which is equal to S8. So please, I want you to see the difference now. So S4 now is S4y is equal to S8 of the original equation. Now to find S10, S10 will be S5 in this instance. So I have to multiply this again by y. So that will be y raised to the power 5 minus 2y raised to the power 4 plus y cubed minus 16y squared equals 0. So let me now express it in terms of our s, the power s, the powers and s. So this will be s5 minus 2s4 plus s3 minus 16s2. So in this instance, we don't have any constant. So it has made the job very easy for me. S5 minus 260 plus 50 minus 32 equals 0. So you have S5 minus, this is 210. 210, and that is 242 is equal to 0. So S5y is equal to S10, which is equal to 242. So our S10 is 242, our S8 is 130, and our S6 is 50. So this is S6, S8 here, and this is S10. So substitution makes it very easy. The equation x cubed plus x minus 1 equals 0 has roots alpha, beta, gamma. Show that the equation with roots alpha cube, beta cube, gamma cube is y cubed minus 3y squared plus 4y minus 1 equals 0. Hence, find the value of alpha raised to the power 6 plus beta raised to the power 6 plus gamma raised to the power 6. Now I have this equation. X cubed plus x minus 1 equals 0. Now, make y equals to x cubed. So y will be equal to x will be equal to y raised to power 1 over 3. Now let's substitute y equals to 1 over 3 into the equation. So I have y into 1 over 3 cubed plus y raised to power 1 over 3 minus 1 equals 0. Therefore, I can now say y minus 1 is equal to minus y raised to power 1 over 3. Now let me cube both sides. Cube both sides. So I can cube both sides. So I have y cubed minus 3y squared plus 3y minus 1 equals to minus y. Now let me bring it back. So I have y cubed minus 3y squared plus 4y minus 1 equals 0. So is it the same thing with what we have here? So that was already done. So the next one says that we should find the value of the square x with alpha is power 6, beta raised to power 6, and gamma raised to power 6. And that is summation alpha squared y in this situation. So S6. Try to understand. So the sum of this one raised to power 6 is sum of squares of this one. Now and S2y will be equal to summation alpha y all squared minus 2 summation alpha beta y. So what is summation alpha y? That is minus 3 over 1, that's 3. What is summation alpha beta y? That is 4 alpha beta y, that is 4. So S6, which is equal to, so S6, which is alpha is power 6 plus beta is power 6 plus gamma is power 6, is equal to S2y. And this is the formula for getting it. So that's going to be 3 squared, that is alpha square y, plus minus 2 into 4, which is 9 minus 8, which is equal to 1. Therefore, alpha is power 6 plus beta is power 6 plus gamma is power 6 is equal to 1. That's the solution.